Hello everyone, welcome to our YouTube channel, The Engineering Project. In today's tutorial, I am going to show you how to interface Arduino with shift register 74HC165. This shift register 74HC165 is used to increase the input pins of Arduino Uno. It can be interfaced with any kind of microcontrollers like PIC microcontroller, Atmel or Arduino, etc. I have shared the link of this tutorial in the description of this YouTube video, and when you click on that link you will come to this page on our blog, and from this page you can easily download this Proteus simulation along with Arduino code. I would suggest you to have a look at this tutorial as well. Read it for once so that you can have a better idea how this shift register works. And in order to download this Proteus simulation, you have to click on this button, download Proteus simulation and code. I have already downloaded this folder, so I'm gonna open it, and from this folder you need to open this Proteus simulation 1, and we are also gonna open our Arduino code to get the hex file. That's the Arduino code which we are gonna use, and here's our Proteus simulation. And you can see here we have used Arduino Uno, and I have connected this virtual terminal with Arduino Uno so that we can have a look at the data coming from these ports. I have connected this shift register 74HC165, and I have used these logic states to provide input to all these 8 input pins. This shift register is gonna receive this data in parallel, and then it will serial out this data from this SO pin. Via here I have connected this SO with pin number 11, and we will display this data on our virtual terminal. So now I'm gonna compile my code to get the hex file. And as you can see here we have this link to our hex file. I'm gonna copy it and I'm gonna add it in this Arduino on our Proteus simulation. You need to add this link to the hex file here in this program file section. Control V, OK. Now let's run the simulation. And as you can see here we have this data on our virtual terminal, and let's change one of these logic states. I'm changing it from 1 to 0, and you can see here we have this data updated. P1 now has gone from 1 to 0. Let's change another one, and you can see here this one P3 has changed. And that's how you can increase your input pins quite easily. One chip of 74HC165 provides us 8 input pins, but we can also place multiple 74HC165. So here in the second simulation I have used 2 of these chips 74HC165, and let's compile our code again. But here you need to change the number of shift chips from 1 to 2, because now we are using 2 chips. In the Proteus simulation we need to add our hex file in program file section. Control V, OK, and now run our simulation. And you can see here we have this data for all 16 inputs. If I change this one from 0, you can see from P1 to P8 we have data for this U2 shift register. So let's say I'm making this 1, you can see this P1 is 1 now. So if I make it 0, then P2 is 0 now. So our first 8 data pins are from U2, while the second 8 data bits are from U1. So let's say I'm changing this one from 0 to 1. So our last one P16 has changed from 0 to 1. I'm changing this one, so this P14 changed from 0 to 1. So that's how we can change any bit here, and all these input pins are displayed on our virtual terminal.